We're asked to find the radius of convergence and the interval of convergence for this series. And so we have some tools in our tool belt to help us find whether a series converges or diverges. And the one that sticks out to me, since I'm seeing exponents, or the variables in the exponent, is the ratio test, where we evaluate the limit as n goes to infinity of the absolute value of the next term divided by the current term. All right, this lets us do some pleasant algebra. And if L is between 0 and 1, not including the endpoint, then we know it converges. So that can help us construct that interval of convergence. So let's do that. We're going to evaluate the limit as n goes to infinity of a sub n plus 1. That means we're just plugging in n plus 1 wherever n is. And then we're going to divide that by the current term, by the nth term. And so we know how to divide two fractions. We're going to evaluate the absolute value too, but we know how to divide two fractions. We flip and multiply. So this is 11 to the n plus 1 power times x to the n plus 1 power over, and I'm going to expand this factorial. This is n plus 1 times n factorial. And then we're going to multiply that by n factorial over 11 to the nth power times x to the nth power. And so we're going to see some terms cancel out, some terms simplify, like this n factorial cancels out. Got 11 to the n plus 1 over 11 to the nth, so that's 11 in the numerator, x to the n plus 1 over x to the n. You subtract those powers, and then you've got just x. That's all over n plus 1. And then we're still evaluating the limit as n goes to infinity. Let's see. So since we're trying to make this converge, we need this limit to be less than or equal to 1. Normally at this part of the process, you try to set up an inequality and try to find a value for x. We need it to be between -1 since it's absolute value. We need x to be between -1 and +1, so we put the inequality in here, but we actually don't have to do that for this problem, and we shouldn't, because the limit is as n approaches infinity. We have n in the denominator of the fraction, right? So n is getting infinitely large, and then we're adding 1, so it's a really, really big denominator. And if you pick any constant for x, it's not going to matter because that's not going to infinity. This is like the limits we evaluated at the beginning of our calculus course. The limit as x goes to infinity is 0, right? Same thing here. This limit is going to be 0. So this thing is going to converge everywhere, regardless of what value for x. For all numbers x, this is going to converge because the ratio test shows us that all the values for L that you're going to get are going to converge to 0. Okay, so the radius of convergence, it's actually all values. It's an infinite ratio of convergence from -infinity to +infinity. I'll have to take a look and see how how WebAssign wants us to type that in, but maybe it'll be -infinity to +infinity. I'll look in just a second here. Oh no, that would be down here. The interval of convergence, -infinity to +infinity. Okay. Oh yeah, the radius. Sorry, this is saying the radius. So like, how long is it from the center to one of the edges of the interval? Well, it's an infinite amount of length, right? From the center between -infinity and +infinity. Well, the radius is also infinity here because it's every number for x, every possible value for x, it converges.